Hello guys, welcome back to new video. And in last video we were discussing about uh, the topic of the isolated system, and I do hope that that topic got amazingly clear with you guys. And if you haven't checked the video, do check that. That was kind of amazing. Here is a lecture, and if you see today's topic, that is elastic and inelastic collision, that is kind of relating to the accelerated system as well. So let's get into it without wasting time. The elastic collision, if you see elastic collision, there's simply a thing is mentioned. The elastic collision, simple definition, the most simplest definition is written over here, that it is written momentum. We are done with the video of the momentum. If you haven't checked that out, do check that, because in that I've explained what momentum is. So momentum and kinetic energy are conserved in a elastic collision. What does that mean? Now this means that kinetic energy is representing over here the motion of the body, right? This is the motion of the body, kinetic energy in this case. This is not about the heat and all the stuff in this case. This is about the motion of the body, right? So conserved means, you can say conserved means saved, protected, or the same. It remains same. It is protected, and the result is still the same. Same same is the best word for it according to me. Okay, so yes. So you're gonna see before collision we have got M1 and M2, right? Now they have got their initial velocities, and V2I and V1I. Then after hitting objects in elastic collision, what will happen is that they will bounce back. Now if you see the direction of the arrow, here it is like this and here it is like this. In the case, the direction becomes opposite, and the mass is still the same, and the velocity is still the same. Remember this, in this case, the law of conservation of momentum is being followed. And this elastic collision, all it is not possible in isolated system. It is only possible in isolated system. This is very important point, because in real world, there is no conservation. Like, there is a minimum loss, but there is always loss of energy and all that. This means, if you take a real life example, if you're throwing a ball on a wall and it comes back with the same speed, and these are special cases of the momentum we'll talking into about that in our upcoming videos. I don't want to get into those, but over here, does the momentum of the body is conserved, and the kinetic energy is conserved. The speed remains the same before and after collision, and the amount of motion in the body is the same as well. Now there is it is written that changes in momentum are equal and opposite, right? The motion of the body is equal, and it is in opposite direction, and the energy of the particles in the body are still the same. If we talk about inelastic collision, this is taking place in isolated system. Now if you see, before collision we have got this body, this was m1, and this is m2, and they have got a collision. Now after collision, if there was elastic collision, so they may have got come back, but this does not happen, right? So what happened is this: the body got stick to it. Over here in this case, they both got into this direction. Now this depends what happens in elastic collision. If for suppose this body is very less weighted, and the body B is bigger, so in this case the body A got attached with body B, stick to body B, and they went forward. But what if we've got a case like body A was like this and body B was like that? So in this case, so uh, this one, the speed would be the same, while this one is equal to that would multiply by 2. Now these are all the cases of the momentum we're discussing in our upcoming videos, but this is just a example of the inelastic collision. And this is not only the case in elastic collision which I've shown you in diagram, and this can be a case like the blue body is stopped. This can be a case that the pink body is and the body B is moving into the direction of the body A, the pink one. So this depends on the factors like mass and kinetic energy. Uh, in this. So this means that the, as I mentioned, in this collision, the motion of the body is dependent on the kinetic energy and the what we say, the momentum. So this means that kinetic energy and momentum aren't conserved, and this is only happening in the insulated system. If you throw a ball, and you will see that it will not bounce back to the same position. So this shows that the momentum was conserved, but the kinetic energy wasn't. And I would like to tell you that in the isolated system, the momentum and the kinetic energy of a body are conserved, while in isolated system, the momentum is conserved while the kinetic energy is not conserved. So this was the concept. I do hope that you've got it. Meet you guys in the next video. Till that, goodbye.